welcome to my channel and welcome to my website. My name is Daryl and this is Programming in Any Language. The website is www.black-duck.com. It's where you will find all my videos organized in logical order. You can begin with the basics and then move on to the advanced concepts. You can also start with the speed track and build an application from scratch, which should pique your curiosity with a desire to learn more. Well, when it comes to file processing, it doesn't take too long to understand how to write the code to read and write a file. But when it comes to implementing the process in a program, it can be easy to make mistakes you don't expect. Today I've got two short videos here that demonstrate that point. The first one is pretty obvious when you look at it. Take a look. Okay, this is a project written by a student and it works. But take a look. If we run this thing, it suggests that I enter the speed in miles per hour, which I will, 50 miles per hour in there. I'll then put in 5 hours for my travel, and I'll calculate, and the output file will be stored in distance text file, but it looks like nothing happened. If I go and examine this little particular file, which I have right here, and dig into the bin debug folder, there's a file written here. And there's the 50 to 250 miles per hour that it actually traveled. So it did write the file. But the problem here is the program doesn't tell the user. As a programmer, yeah, this will work for you just fine. But if you're trying to turn this thing into a user, it doesn't work well. So what you should do is get in here, and a message box will be fine. You could also go ahead and put a label in this thing, which we can quickly do. Drag it down here. Put down file has been written. Maybe make it red. In the 4 color. And that coral red. Good. And make it invisible. And give it a name. Call it LBL file message. Make it bold. And maybe make it a little bit larger. Center it on the form. And then go in there and write your code. Go into your calculate button. This code is a little crazy too. It's written by a student when they were first learning how to do this. Here we've got a file actually created. Output file equals file. He's got all this stuff going on here. We're all done. Close the file. Right down here might be a great way to say LBL message dot visible equals true. And of course you want to close it off someplace where it says false, probably in the clear button. You can turn this guy off. LBL visible equals false. Now we can run our program. Start it up. Same program comes up. We'll put in our 50, put in our 200, put in our 5, hit calculate, and file has been written. It pops up. Nice. Clear it off. It goes away. That's what you want to do. You want to actually inform the user, let them know that something's going on here. Right. As a programmer, I just want to multiply speed and time and write my list to disk. What can be easier? I know what's going on. But give that program to a user who has never seen it before. It just sits there. That's what it looks like. There was no indication a file was actually written. As programmers, we need to look at our programs from the user's perspective. They've never seen it before. Take this next one. This program works. Well, it does until you mess up, and then it doesn't. And you end up with a system error. Check this out. Here's another program that has a flaw in it. Let's go ahead and run this guy, take a look at it, and see if we can spot the flaw. Again, it's a miles per hour program. Type in 50, type in 5, and calculate, and output save to disks. That sounds great. Okay, great. That's super. So that's working right. But let's go ahead and rerun this program again. But this time let's put an error in there. So let's go ahead and start it. We'll put in garbage and garbage. Do a calculate. Incorrect format. It doesn't clear anything off. It should. We'll go ahead and put in 50 and 5. And it seems to work fine. So let's go ahead and kill it again. We'll run it a third time. This time we'll put in a negative 50 and a negative 5. Check for negative numbers. Do a calculate, an error. Okay, great. Let's go ahead and put the right numbers in here. 50 and 5. Wow, we get an error. Okay, what's going on here? It checked for garbage. When we put in negative numbers, something happened because it works fine until you put in negative numbers. That seems to throw a flaw in there. If we go in and take a look at this thing and actually run it again and do a run on this. Actually, we're going to go into the code first. And we'll set a breakpoint at the try. We'll do a run on this thing now, and we'll take a look at this guy and see what's happening. If we put in that negative, minus 50 and minus 5, and do a calculate, program's going to stop. And if we step through this using F11, we get the speed. We can actually go ahead and bring a watch in here and take a look at these things and see what's actually going on here by adding a watch to speed. Adding a watch to time. And adding a watch to distance. And as we run through this program, we can see a change. It goes in and grabs the minus 50. It grabs the minus 5 just fine. Then goes in and opens the file. Output X2, append true. So it's going to do an append to the file here. But then it's going to go ahead and check the messages. And it says here, enter a number greater than or equal to 0. And so we get this message going on here. So, okay, great. We don't have anything going on there. What's going on? So we go ahead and hit F11, do our catch, come back, and the program comes up allowing us to actually put something in again. Now, if we go in and put the right numbers in here and do a calculate, our program comes back in, goes through the try, gets the speed of 50, gets the time of 5, and goes in and opens the file again. And as soon as it tries to do this, it gets an error. The reason for that is it never closed the file before. So in other words, our checking, what's happening here is our file is being opened up before we actually do any checking of the processing going on, what the numbers are. If we find an error down here, we need to close that file. Better yet, what's even better is don't open the file until you've got all the correct data in place, then open it, do your processing, then close it. That'll solve your problem completely. So that's what's going on wrong right here, right now. Can we fix this easily? Actually, we'd have to bring the stream writer down here. We would actually go ahead and comment this guy. Let's go ahead and get rid of this and let's fix this and bring this thing down. Control C here and put it just before the 4. So now it's part of that loop there, and we'll comment out this guy so we're not using it anymore. Now we'll go ahead and stop our debugging. We'll run the program again. Oops, let's get rid of the breakpoint. Let's do this right. Okay, start program again. Breakpoints out of there. We now can put in our negative numbers, minus 50 and minus 5. Run it. Get the same errors we got before. Okay. Nice to have a clear button in here. Do our 50 and our 5, the legitimate numbers here, and do a calculate, and it works. Output save the output.txt file. So that's the point here. Don't open your file until you've done all of your checking beforehand. Then your programs will run flawlessly. They'll run much better. Wow, program that works but doesn't if it catches an error. Pretty tricky. Yeah, you need to keep that file open and that file closed very close to the processing of the data. Verify all of your data first before even thinking about processing it. That's an easy mistake to make. What you need to take out of this video is let the user know what's going on in your program. Check all your data before you process it. Open, process, close. Keep this close together. And test, test, test. Can't ever test too much. See you next time. Thanks for watching. Don't forget to use the website for easy access to all my videos. If you get a chance, please subscribe. That way, you'll be notified when something new is available. We'll see you in the next video. Take care.